Thank you. So Fernando and I kind of accidentally got on stage, and I want to share the story how that actually happened. So let's set some context for this talk before we dive into the details. I think it was late April this year in Amsterdam, my colleague Eric, who's on the left-hand side of this picture, and Stavros, who you have seen on stage yesterday, they introduced the Search Relevance Workbench for OpenSearch. And specifically, they shared one feature, the first one that we implemented, which was already referenced yesterday, and that is called eyeballing. And eyeballing may be not clear to everyone, so what I would like to do is actually show you briefly what eyeballing is, so that you know what we mean when we say eyeballing, and why it's interesting in the context of RAG evaluation, and specifically how we think that it can enable a human-in-the-loop system for RAG evaluation. And in the end, we would be highly interested to hear if you think that it makes sense, because it's kind of a hacked prototype that we are going to share today, more an idea and not a polished product. So we are pretty much up for gathering any feedback that we can get. Of course, positive better than negative, but please don't hesitate to share the negative aspects as well. So, okay, that is pretty small, but that's a little better, and we can increase that. So, let's show you what eyeballing actually means. And eyeballing is pretty simple to explain, because what we have is we have one query, we have, in this case, one index, the e-commerce index. And what I'm going to share is, I'm going to share two. Let's see, how do I get to the next tab? Not, oh yeah, that one, maybe. Is it going to load? It is loading. Sorry about that. We have two what we call search configurations. And a search configuration in our case really is nothing more than an OpenSearch query. So in this case, I have a simple multi-match query. I'm searching across a bunch of fields. I'm going to copy that. And I'm going back to, oh, I'm not going back. I'm going back to this one here and start all over again with laptop, e-commerce, e-commerce. So the first part of the demo is already bumpier than I expected, but that will hopefully help us get through the second demo a little easier. So what I have is two simple search configurations, one on the left, one on the right. I just changed the weight of the title field. So we're searching across a bunch of fields, and on the right-hand side, I'm saying I want to see, eyeballing, right? I want to see what changes when I go from a title boost of 1, so no title boost actually, to a title boost of 25. So I don't know what will happen. I just want to see how different are the results, so that I, as, let's say, a non-technical person, a product manager, a product owner, I just want to quickly assess by looking at the results, do these results make sense to me? Is that a change that I would like to see in production, yes or no, without looking at any scary metrics? And in this case, I'm seeing 10 results on the left for my non-title boost query, and on the right, 10 products for my title boost query. And at the top, I see I only have one common item. So by a simple change of just adding a title boost of 25, we go from, we basically have a completely different result set. And the resolution on screen is not that great. I can see it on my screen here. There's actually a line from position 3 to position 1. So one single product is left, and that moved from 3 to 1. So this is what we mean by eyeballing, right? We can now have humans that can quickly assess change for one individual query to search configurations. So nothing like, how did my NDCG change? Yeah, it's just, does it make sense or not, what we are seeing here on stage on the screen. And nope. I need you to get back to the slides, sorry. Now, when Eric and Stavros gave that talk, already saw more than we wanted to see maybe, they introduced eyeballing, and then Fernando approached Eric and said, hey, eyeballing is cool, I work on RAG evaluation. Is there a way to actually combine RAG evaluation and this notion of eyeballing? Because sometimes you don't really know in RAG what has changed under the hood maybe to actually see what are causing these changes and the difference in answers. So how can we use a human-in-the-loop approach by using eyeballing and RAG evaluation? And yesterday at the bar, where we had alcohol-free beers, a jazz band played, and Fernando and I did, of course, not do final presentations for the slides because we were perfectly prepared before we arrived here. And now we are here on stage presenting this idea of eyeballing together with RAG evaluation. And we are using, let's say, a tool that wasn't specifically developed for RAG evaluation. It was developed more for the consumer-like classic, I get 10 blue links search result page. But this is the basic idea behind our talk. And as I said, please be prepared to give us feedback because we want to know, does that make sense or not? And Fernando will now cover a couple of the details behind RAG evaluation specifically.
Thanks. So so at Alpha we work with traditional metrics like NDCG, precision, and so on. And for me, it's kind of it's very easy, or like for people, it's very easy to kind of focus too much on these numbers and then lose track of what's actually happening for real users, right? So you cannot come to a user and say, well, NDCG went up by 0.001. I mean, what does that mean? So what I liked about this approach is that you can actually see what is actually changing. So to motivate a little bit how we did this, I want to go back all the way to 2022. And then this is how the type of RAG systems would develop back then. So you have a LLM connected to vector search. And then you ask a question, you pass the question directly to the vector search, you get some hits, then template it into the LLM to get an answer. What if it doesn't work, right? What if this approach is not working as expected? Maybe it's hallucinating, it's telling you something that is not correct. What can you do? Well, you can just change the prompt, right? So you can say, oh, things step by step, or grandma is going to die if you don't answer correctly. And that should work pretty well. The other option is you can change the vector search, so you can just fine-tune the model or use a different model and so on. I mean, all of you guys are very good engineers, or cracked engineers, as they say in San Francisco. So I don't have to say it, but RAG doesn't need vector search, right? So that's kind of clear. I have heard about this from actual people thinking that you need vector search for RAG. But if you look at more modern, still simple RAG solutions, it looks more like this, where you have the LLM now has access to tools, right? So tools are converted into just tokens, right? It's part of the prompt. There's some special beginning and end tokens that is kind of templated. So the tools will be, the LLM will decide what tools to use, right? So it can decide to use a search, what query to pass, what filters to add, and so on. So what if the answers are not good in this approach? What can you do? Well, you can do the same as before, right? Change the main prompt. But now you can also change the prompt of the tools, right? So you can say, well, now you have many search engines, or Maybe you add a lot of keyword heavy queries in this one and use a lot natural language on the other one, and so on. And as I mentioned before, the search engine can be anything, right? So it can be BM25, vector, hybrid. You can tune like the parameters. You can fine-tune the embeddings and so on. So you can change a bunch of stuff, right? So there are many things you can change here. If we now move to the more complicated agents, for example, that was mentioned in the last talk, they look more like this. So you have some sort of orchestrator that is deciding what to do, and it may have access to external APIs through MCP. Just the prompts come from an external system. Actually, you don't control that. But the agent can decide to either call more agents or call the tool, or the sub-agents can now do search and use memory, and it's very complicated, right? So, and in this case, if something doesn't work, well, now you can change any of the queries from here. So, summarizing, and it's kind of all saying, but with just GenAI technology, prototyping is very easy, right? You can change many things, but how do you know it's working? That's the hard part, right? Because the outcome is going to be natural language text, or it could be like a multi-page report, right? So seeing that and figuring out whether it's correct or not is tricky. And as you described, you can change many things, from the retrieval pipeline to the processing steps to the agent architecture, use GraphRag, memory, change the LLM, and so on. So how does that work actually in practice, right? So if we go to enterprise and try to implement some solution like this, some agents, they might have, depending on the kind of maturity of the team, right? So we typically work with IT teams or with business departments directly. They might have some queries from the previous solution. Maybe think about like a customer support agent, right? So they have existing queries maybe. But in reality, they will say something like, well, these queries are not very good, right? Because we know the system is not very good, so therefore queries are not good. So we try to convince them to come up with some good queries so that we can evaluate the system. So they might come up with maybe 10, 20 queries. And then you can basically take these queries, create a first prototype of the agent, evaluate, then come back to the experts and say, OK, here are the answers. Please tell me how good they are. They will probably happily evaluate maybe 10 or less. And then, OK, we work a little bit more. We change the parameters. All of the knobs that I showed before, we tweak them. And then once we think the solution is better, we go back to the experts and say, OK, now please tell me if this is better. And most of the times they will be surprised and say something like, oh, I thought it was like a one-off exercise, right? Am I going to be doing this all the time? Sorry, I don't have time for this. Very busy, which is understandable. So what can we do about it? So I mean, naturally, you can say, well, we're using LLMs. LLMs are very powerful, and they can reason. So what we can do is, for example, feed the answer to an LLM, which we call a judge, and just prompt it to evaluate the quality of this answer based on the criteria that the experts have decided. So in this case, it's just a very generic prompt, just saying take accuracy into account, the completeness, and this is based on the hits that you are seeing. So you can play this game, and then let's say you have multiple versions of your system. In this case, I'm calling them RAG v1, RAG v2, and so on. And then you ask the judge to evaluate the quality, and you can just average the quality for each query, and then this is something what you will see. Now, if you're able to convince the actual domain experts to do the same exercise, you will find something different, right? So the LLMs are a bit too optimistic, so they will agree most of the time that something is relevant, even though it's not. Whereas the experts, they know what they're talking about, right? So you will see some disparity like this. And so I'm going to do now magic tricks. So I'm going to shuffle the bars. So I'm going to keep the both of them together. I'm just going to order from the lower performance to the highest performance system. So you see something like this. And if you squint your eyes a little bit, you will realize that there is some sort of correlation, right? So we are saying like, okay, definitely this is the worst system, and this is the best system. And both the judge and the expert agree. So with this information in mind, the next thing you could think of is like, sorry, before that, we have validated this kind of empirical result across multiple domains. So some of these plots that you can see here. And also in literature, you can find all the people that are doing similar things. So OK, now the question is, why don't we just ask the LLM to compare 2 answers instead of 1, right? So the situation is now like this. So you have 2 RAG systems. You pass the same query to both. So you will now collect 2 answers, of course. So now you will pass both answers to the judge. And then, oops, sorry. In the prompt now, instead of saying, tell me if this answer is good, you will ask, compare these 2 answers, and then tell me which one you prefer, right? So again, there is going to be criteria that you will extract from the domain experts, like maybe, is it actually using the hits as the ground truth or not? And is it understanding the domain and so on, right? So you can tweak this meta prompt. But the answer, what you are looking after, is for LLM to tell you which version is better, A or B, or V1 or V2. So let's say you're playing this game for different queries, right? So for some queries, one version will be better, and for other queries, the other version will be better. So you can think of ranking these systems like V1 and V2 in that way, like which one won more times. That's one thing you could think about. But the problem is that what if you now introduce more versions, right? So now you have a situation like this where you play, let's say, V3 against V2, and then, of course, V2 sometimes wins, V3 sometimes wins. So how can we create a rank from this, right? Because before it was kind of simple. The one who has the highest average is the best model or the best system. But in this case, it's a bit more complicated, right? Because we're playing pairs of agents or pairs of systems. But locally, chess has an answer, right? Because in chess, you have players that start with some initial rank. So this is called the ELO system, the ELO ranking. And in this case, what you do is a game for us is like query, right? So a game is between 2 agents. And then you are going to ask an LLM which agent had the better answer, as I mentioned before. And the algorithm is if A wins, so agent A, and its ranking is higher than B, then the score of A increases by a little bit, whereas the one from B decreases by a little bit. Whereas if same situation as before, A wins, however, its ranking was lower than B, then you are going to penalize that, right? So the score of A will increase by a lot more, and the score of B will decrease by a lot more. So I have some examples now. So this is kind of the algorithm that I just explained. So the new rating is equal to the old rating plus k times this difference of scores. And so the difference here is actual score minus expected score. And actual score is quite simple. So if you win is 1, if you draw is 0.5, and then if you lose is 0. And the expected score is some sigmoid here that has to do with relative scores or like relative rankings between the two agents. So we can use k equals 0.2 for this example, but usually a lot higher. So we have an example here where you have 2 players that have the same score, right? Let's say they are new players. And we have a situation that A wins. So what does that mean? So A won, therefore the actual score is 1 and for A, and for 1 for B is 0, right? From the first rule. Now, if you put these 2 scores into that formula there, you will get the expected scores is 0.5 or both, right? Because they have the same R. And so they increase, or like the change in their score, which is this k times the difference, is going to be 32 times 1 minus 0.5, which is 16 for A, and for B is the same, but it will become minus 16, right? Because you have 0 minus 0.5. And then put it back into the rating, you get that A went up by 16, and then B's went down by 16. So it's kind of simple. What if you have the opposite case, right, where you beat the stronger player? So that's kind of less likely. But let's say you have the score of B, it was 1700. So the actual scores are the same as before, right? So A equals 1, B equals 0 for the actual scores. The expected scores now are different, right? So for A is 0.24, whereas before it was 0.5. So when you do this computation again, you see that the delta is 24 as opposed to 16. So it means that because it was a less likely event, you are giving like increasing the score of A by a lot, and then also decreasing the score of B by a lot, or like more than before. And the last case is the expected one, right? So you beat the weaker player, which we will expect to happen most of the time. So I won't go into the details, but the point is that the deltas are a lot smaller, right? So both A gains a little bit of score, and then B also loses a little bit of score. So yeah, you can wake up now if that's worrying. So what we did last year, I think, was to create like a package, open source package for doing these calculations, these ELO games, for evaluating agents. If you're interested, you can look at this QR code. But the idea is that you will collect answers from multiple systems, and then you will feed back that into the package. What it's going to do is going to first evaluate from the hits that each system retrieve. It's going to just rank, evaluate how relevant the document is for the query. And then it's going to feed that information into the next step, where you will combine the answer of the two systems, the scores of the previous one, and then just ask the LLM which one is better, right? So the thing I was explaining before. And then finally, you will run this algorithm for each game, and it will give you this table of like ranked agents. So the top one is going to be the best one in this case. So let me go into a bit more detail here. So the data that you will feed to the system looks like this. So you have a bunch of queries, right? So in this case, about evaluate text summarization techniques. What are the hardware accelerators using AI? And then you get a bunch of retrieved documents, right? So from each of your systems, you have a document that has like a chunk here. We're talking about Roach. And then you also collect the answers, right? So for each agent, you will have an answer, saying like, okay, these are the techniques for text summarization. So this is kind of your input data. And then you have two prompts, basically, or meta prompts. The first prompt is going to tell you, or it's going to instruct the agent to evaluate the relevance of each of the documents against the question, right? So this is just a standard. It's actually very old, so don't take pictures. Probably need to go into the current version of the project. But it's very simple, right? Saying like, compare the question and the document and tell me if it's relevant or not based on some criteria. This is the answer that you will see. So for example, the document 1 for query 1, it says very relevant because blah, blah, blah. And then for this other one, it says is somewhat relevant. And then finally, you have the second prompt, which is the one that is going to compare the two answers side by side. So in this case, we are saying you will be provided with the reasoning explaining why the document is or not relevant, right? So this is this part that we just did. Now it's going to ask the LLM to explain why each answer is correct or not. And then finally, it's going to ask to give a letter, like so A, if assistant A is better, assistant in this case is an agent. B, if the B1 is better, or C, if it's a tie. And then you just put the documents with the relevance, and then the answer of A and the answer of B. And finally, you will get some table like this, which is saying, okay, for this game, right? So you have a game which is query 1, agent A versus agent B, and it's going to say, well, assistant A response is very brief, blah blah blah. Then B's is more comprehensive. Finally, B is the winner. So this is the type of answer that you will get. And then if you run that for a bunch of variations of your agent, this is typically what you will see. So the top 3 ones are the best ones. And yeah. Now, I'm not going to pronounce this, but the point is that these are all kind of agents evaluating each other's answers. So how good is this really? Like, who is actually watching the judge? Because winning is very nuanced. So I have an example here. So I ask 2 different agents who are the main deep learning researchers in the Netherlands. Okay, this one is just answering straight away. I think, yeah, it's citing some documents here. This one is saying, actually, well, wait, what do you mean by main, right? Is it like more famous or a bigger group or bigger grants, right? So what does that mean? And in the end, it just answers something, and then when you run that through this RAGElo, you will see that while it's saying that B is better, because well, it's saying that both approach it kind of differently with different levels of detail, and then it's saying at the end that B is more comprehensive and informative, and therefore B won. But I mean, I don't know, maybe I don't like the fact that it's asking what do I mean by mean and by main, and I just want that to be the winner, right? So if you don't really look into the data, you will never realize these small details. And that's the reason I kind of started all of this thinking about using RAGElo with SRW.
So with that background now, we can try and identify if we can hack together the Search Relevance Workbench, which originally wasn't meant for RAG evaluation, and see if we can actually use that and have a solution that actually powers RAG evaluation. And Fernando will help me get to the demo, I guess.
Yeah, sorry.
And so we already talked about the Search Relevance Workbench, right? So now we are going to show you how RAGElo works and how we can actually import the RAGElo results into the Search Relevance Workbench and then use this eyeballing tool to compare results side by side. So having this human-in-the-loop notion of it.
Let me set it up now. Yeah, so this is kind of our internal tool that we use. I probably not see very well. So I basically just added a new section here. It doesn't matter what you have on the left, but the first thing it's doing is connecting to SRW to download the search profiles. Mm-hmm. But in our case, it's not called search profiles, right? It's called agent configurations.
Right, we are kind of misusing it, but eventually, under the hood, it's just JSON, right? And if we have a model ID in this JSON, or if we have an OpenSearch query in this JSON, I mean, the system doesn't really care. So that back-end part of it, that definitely was more the easy part, where we say, yeah, that definitely works pretty well. So we can use the term of a search configuration that typically is just a query and stuff in more information so that it makes an agent configuration that helps us bringing in agentic world, or at least the RAG world, into the Search Relevance Workbench.
Yeah, so in this case, I have a small or like a simple agent that is, I think, is using some two tools. One is like a search tool, and the other one is like a sitemap crawler thingy. And I have a bunch of them here. So I think this is one is GPT-5 Mini, temperature of 1. And then there's another one which is the same agent, but is using 4.0. So the idea here is that, well, one of the details before I move on is that one of the previous slides I showed was how you have the game between multiple agents. But one of these limitations of SRW, at least at the moment, is that you can only do 2 at a time.
Yes, yes.
So here I will only select 2. So okay, that's kind of locked in. So these 2 agents will play against each other, and now we need to define what is the games that they're going to play. So created this small benchmark on AI research, which has 25 queries. And again, this part is being taken from SRW as query sets. So in this case, it's the same name.
And a query set is just a collection of queries, right? So this just means we have 25. In this case, it's research questions in there. And one of these research questions can be like, who are the main persons in the Netherlands dealing with AI research or anything like that? So they are basic questions. You will see these in a moment.
Yeah. Okay, so now it's saying okay, we have selected these things, and then I can click here, collect answers. So if this is the first time you you do this, of course, it will actually go ahead and call for each of the queries, each of the agents, collect everything. But actually here I'm also using, well, not SRW, but actually OpenSearch to store all of my answers into an index. And that's why it's saying, well, it already exists, because I already played these two games or these two agents before. So it's just saying, OK, I already knew this, but if not, it will be actually computing all of the answers here. And then finally, the evaluation part. So there are these two buttons, evaluate pairwise and pointwise. I didn't really talk about pointwise, but it could also is something that you can also use to supplement your evaluation, right? You can just say, rank the answer on the, I don't know, like accuracy and so on. But in this case, we're demoing more like the ELO-style tournaments. So I can click here on evaluate pairwise. And what it's going to do now is to go through the process that I showed before. So it's going to be like evaluate each of the hits, and then feed the information into these pairwise games, and then ask the LLM to say which one is better. So I have some answers here, and the final result. But the point is that since it's integrated with SRW, there is also this link. So if we open that, we'll go directly to the experiments in the SRW dashboard.
And now you can already see that we are maybe not the best user experience persons. And also that the Search Relevance Workbench wasn't initially meant to be a RAG evaluation system. So again, this was hacked together like fairly quickly, not just yesterday at the bar, but the weeks before yesterday at the bar. And what we now have, so the Search Relevance Workbench, if we compare two search configurations for one query set, we want to know how different are the results, not only for one query, but for 25 or 2,500 queries. And to know how different they are, we typically look at search nerd metrics like RBO or Jacquard. So both of them give us a notion of how different these are. Jacquard is more the difference-only based metric, and RBO takes into account how different the ordering also is within these result sets. And we already see, so one is identical. The closer to 0, it's very different. So we already see that the two agent configurations give us very different results. Yeah? So that already is maybe a first notion of risk, what I like to call it. Yeah, so the risk here, a change, the higher, the more change we see, the higher risk we expect, because more risk means users may be, I don't know, overwhelmed or confused by the results. What we are also introducing now is the ELO score. So this is now technically outside of the core Search Relevance Workbench functionality. So we are now also telling which of the agent configurations now is better. And in this case, we clearly see that ELO Agent 1 with a score of over 1100 is better than ELO Agent 2 with a score less than 900. So this is not really eyeballing directly the results, but we can see one glance which agent is the better one. And now we also have this explanation here. So I will go over that very quickly, because it is just very clear that this is not UI optimized. But the interesting part here is final verdict, B is better. So this tells us now all together, B is now, it's probably the one with the higher ELO score, right? Should be at least. That gives us, again, this explanation why it is better. From a UI perspective, we would probably need something like only this and a show more that we can see the explanation, or hover over or something like that. So I think options are definitely there. And now what we can do is we can dive into the details of the individual queries. And I will sort by RBO descending now, so that we see now that we have a query where we do have some like overlap. And again, yep, this is not UI optimized, but we can now have a look at, for the query, provide an extensive list of watermarking techniques for generative AI models, we have 2 results in common. We have 9 unique for one agent configuration and 9 unique for the others. And this is now interesting for subject matter experts, right? So we can now dive into this and say, what are the overlapping citations for this RAG answer? And would I maybe expect a different one in here? We now have very technical IDs shown, but we could also have the chunk, or at least the first characters of a chunk shown, so depending on what we actually want to do. And this is now basically where you already see a lot of questions popping up, and also the questions that we have are popping up. Yeah? So how would you, as RAG evaluators, maybe want to have this displayed? Yeah? So I already made the point pretty clear that it's hacked together pretty quickly. We do think that there are a couple of things that really are worth pointing out and valuable, taking over from like classic information retrieval to RAG evaluation. But then the question is, does it really provide like more value having this graphical interface where you can dive into individual queries and say, yeah, citation 4 is moving up for agent B, citation 2 is the same, we have a difference in position 1. So looking at individual queries is something Matthias also yesterday said in the SIG IR challenge would have been valuable. So we are collecting feedback basically, right? And
if you may be paying attention, you might be asking, well, this is a RAG evaluation, so where is the answer?
Where's the answer?
You're only talking about hits, so actually we hacked it so that the top one is always the answer.
And that's why it's different always in position 1.
Exactly.
Which is probably not the best use of an eyeballing tool then, yeah? So again, something that we need to take care of when we redesign the UI so that it actually becomes the valuable tool that we envision and want it to be.
Yeah, and something interesting to highlight when I was running this experiment, or something I maybe didn't realize before having such a tool. Let me see if I can find the example. So if you remember, I was comparing GPT-5 Mini against 4o, I believe. Yeah, so this one. So the prompts are exactly the same. The only difference is the model. And you can already see from this question, which is, how has context size increased for LLMs over the last year? There's a bunch more hits being retrieved by 5 Mini.
7 versus 7, and only 1 shared.
Yeah, and then sometimes I have seen this UI kind of breaks, but okay, that's a kind of a separate topic. But it's something that you can discover, like how more agentic, like, OpenAI has fine-tuned this model to behave in this particular way, right? But without changing anything else on the architecture of the agent, we are seeing that, this can actually collect a bunch of results, more than 10. And if you remember from my lightning talk yesterday, where I was talking about, these deep research agents, so complicated to get the architecture to work. But maybe, these emerging features of LLMs are already enough to do something similar without so many, architectural changes that you need to make.
I think with that we can go to the concluding slide, right? So there definitely were a lot of lessons that we learned. And one is RAG isn't really the use case the Search Relevance Workbench was built for. So we would really have to implement some changes that make it really worthwhile. We compare search result lists with each other, and there we can measure change with metrics like RBO and Jacquard. But I don't feel that we have an equivalent metric for RAG answers already. Yeah? So there's something like how similar are they, but it's not. We don't have the feeling that there are established ones right now. We don't really care. We don't really have a way to eyeball tool calls. So if there's something like web search or searching in a search engine, yeah, that becomes even trickier then when we want to apply the Search Relevance Workbench. That is definitely one challenge that we discovered. ELO is a nice way of like comparing multiple RAG versions and agents. But if we have not 2 agents to compare, but 4 or 5 or 20 maybe, this can become even more complex in the user interface, and you've already seen how it looks like when you compare 2 to each other. And the Search Relevance Workbench APIs we discovered, they were quite useful. So every time we interacted with the backend, we had an easier life than interacting with the front end. So user interface, user experience is definitely a story of its own. And maybe a vibe-coded UI yesterday at the bar would have been the better option of showing what we can show. But I think we are here to gather your feedback, and I guess that is where we ask for feedback and also questions.
Thank you.
Thank you.
Lazy, I start here.
Great talk, and I think there should be more talks which have that crossover between chess and search. All for that. There are quite a few well-known biases related to pairwise ranking, such as in-family favoritism, verbosity, and I saw that you mentioned position bias in your prompt. So my questions were, does telling the LLM to not be biased work? And if it doesn't, what other methods are available to mitigate these biases?
Yeah, it's a good question. So indeed, we try to do that, just saying, oh, don't be biased by the position. Of course, sometimes it works, sometimes it doesn't. Simple thing that we do normally is just to play the 2 games like in reverse. And then in the end, if they, if in one case A wins and the other one B wins, we kind of categorize that as a tie, because there is no definite answer, let's say. There are other ways. I think there's a great paper called ELO with a Z from a zero entropy company, and then they describe other ways of, there's some graph theoretical ways in which you can guarantee that the games are more fair in some sense. So I think there's definitely something to explore.
Sorry if I missed it, but is a game between 2 agent configurations a query, or is it running through all the queries and seeing which configuration is better one game, if that makes sense?
Yeah, so a game is one query,
okay.
And then a tournament, it would be like the entire benchmark or like a query set.
Well, a question from the online audience. What strategies are being used to control the agent orchestrator to not spend too much time and not to spend too much money on something?
That's what we do, I guess.
Yeah, so I mean, we didn't really describe how to create agents in this way. It was more like to explain the how many parameters you can tune in some sense on these systems. But yeah, in general, we use different techniques there. So the simplest one could be like if you have a budget, that is kind of increasing every loop that you make into the call, and at some point you just call it and go directly to the end, where for us, for example, the end in a deep research agent is going to be the one that creates the actual report from the snippets. So there is kind of a simple way of cutting off the cost and the time. Yeah, and there are other ways, just let the agent decide, but that might...
Including an orchestrator would mean we are dealing with a multi-agent system, and that feels like asking for even more problems than we already have.
Yep.
Not taking money into account, actually. Yeah. So I think evaluation becomes even more tricky in that realm. So money is maybe the simplest one to solve. But I think you're absolutely right with the boundaries and guardrails you mentioned. Yeah.
Hi, thank you for your talk and open sourcing the RAGElo tool as well. One question I'm wondering about is like the evaluation over time. So I'm not really sure how ELO works because I'm not that much into chess, but the question is, if one configuration is playing a lot of tournaments and you have a new contestant, like a challenger, it starts with like the standard score. Yep. How do you have an idea how you make sure that it doesn't lose because it's behind time, because it didn't play that much tournaments?
Yeah, So great question. So it's actually something, if you look at chess.com, for example, that's something that they handle because you always have new players entering the universe of chess, I guess. There are different algorithms to make that work. So, ELO, I show ELO, which is kind of the basic one. But there are some more complicated ones that, the simple example I can give you is, for example, if you have a new player, you can, in these first games, increase the K value so that they kind of go up faster and then start decreasing it as they stabilize. But yeah, definitely, like, the ability of onboarding new players is also a reason why we believe ELO is a good approach, because you can kind of cheaply add new versions without having to play every single opponent against each other.
Final question.
This is more a comment than a question. Great stuff. Just as product manager for Search Relevance Workbench, I'd like to emphasize that this is an open source project, and we want 1,000 flowers to bloom. We want everyone to play with it and build things on top of it the way you have. So please take a look at it. Do bad things with it. Do good things with it. Play with it.
Thank you.
Thank you, and thanks to our speakers again.